Welcome to today's lesson on grade 9 mathematics. Today we will be reviewing worksheet 2 on expressions. So expression worksheet 2, question 1a. It's x plus 2 squared minus x plus 1, x minus 3. First thing we need to do is we need to get rid of the square. So in order to do that, we write x plus 2, x plus 2. And then we have minus x plus 1, x minus 3. Alright, so we need to factorize our brackets, and we can do it for both of them. So let me take that away. Alright, there, and these two. Alright, so we are then left with x squared plus 2x plus 2x plus 4. So I don't have space here, so I'm just going to write it underneath, minus x squared minus 3x plus x minus 3. Alright, so now we can write it out nicer, x squared plus 4x plus 4, and then we have a minus x squared plus 2x plus 3. Now we can add or subtract our common items here. So we have an x squared and a minus x squared, which leaves you with nothing. We have a 4x plus 2x, so you're left with 6x. And then we have a 4 plus 3, so we have 6x plus 7. Alright, moving on to B. We have 6x squared y times 8xy cubed over 12x to the 4y squared. So the first thing we need to do is we need to assess the numerator. We're multiplying, which means any coefficient of x or y or any variable is multiplied, but then any factor of x is added. Any factor of x or y or any variable, you add them. So 6 times 8, you're left with 48. And then we have x 2 plus 1 and y 1 plus 3. All over 12x to the 4y squared. So this is 48 x cubed y to the power 4. So now we need to take out what's common between the numerator and the denominator. So, sorry, let's finish this. This is over 12x to the 4y squared. So what's common between 48 and 12 would be 12. And then x cubed and y squared. So we have x cubed y squared. And then at the top you're left with 4y squared. So we have 12x cubed y squared, and at the bottom you're left with just x. So we can cancel those two out, and you're left with 4y squared all over x. If you want to do this another way, so let's go from here, let's solve it in this side. So you can divide obviously 48 by 12, and you're going to end up with 4, and then you can say x to the 3. You bring the x to the power 4, that's a positive 4. If you bring the denominator into the numerator, you make it a negative. So 3 minus 4. And then we have y 4 minus 2. You're left with 4x negative 1 y 2. And because x is to the power negative 1, you take it to the denominator, it becomes positive 1. So you're left with 4y squared all over x. Alright, as you can see, we have the same answer in the end, but we have two methods of working it out. Alright, let's move on to C. C, we have a fraction and a bracket. So the first thing I would do is to try and get rid of the denominator in our fraction. So we need to take out a minus 2x from the numerator. So we have 2x minus 2x, then you're left with 3x squared plus 4x minus 1 all over minus 2x squared. And then over here we have minus 4x minus 1. Okay, so these will cancel. And you have 3x squared plus 4x minus 1 minus 4x minus 1. Take the negative into the bracket. So you have 3x squared plus 4x minus 1 minus 4x plus 1. Do the like terms addition and subtraction. We have 3x squared. The 4x plus 4x minus 4x gives you 0, and then plus 1 minus 1, you're left with 0. So your final answer is 3x squared. Looking at question 2a, we have a fraction in front of a bracket, which means we need to multiply that fraction into every term that's inside our bracket. So we have 9a squared minus 6a minus 3. And we get that because we have the 3/4 minus 12 gives you 9. 3/4 times a minus 8 gives you 6, and 3/4 times a minus 4 gives you 3. So now we can divide each of these by 3. And that will make it easier to do our quadratic equation. So we're left with 3a squared minus 2a minus 1. So for our quadratic equation, we can take out the 3. And then we are left with a and a. We have a negative and a negative, so we have minus and a positive. You're left with 1 and 1 over 3. Alright, so that's our quadratic equation simplified. Moving on to B. We have a bracket in front of a quadratic equation bracket. So A needs to be multiplied onto every single number of the quadratic equation, and so does 2. So we have a cubed minus 2a squared plus 4a minus 2a squared minus 4a plus 8. And I got all of those just by multiplying the a into the quadratic equation and multiplying the plus 2 into our quadratic equation. So we have only one cubed, so we have a cubed. The minus 2a squared, this should be a plus 2a squared, sorry. Minus 2a squared plus 2a squared gives you 0. Plus 4a minus 4a gives you 0, and we are left with plus 8. Final answer, a cubed plus 8. Looking at question 3a, we have a bracket that's raised to a power times another bracket that's raised to a power. But inside our bracket, we already have exponents on our variables. So when we multiply, when we have exponents that are raised to another power, we multiply them. When we have variables with exponents that are multiplied by one another, we add the exponents. Okay. So what we're going to do is we need to cube the coefficient as well. So negative 3 cubed gives you negative 9. Then a to the power 1 times by this 2. So it's 1 times 2 gives you a squared. Then b, we have 2 times 2 gives you 4. And c, 3 times 2 gives you 6. Then we have the same thing here, but each of these are raised to the power of 1. So we have a squared, b squared, c squared. Now, when we multiply our exponents, we add them. So we are left with minus 9a, 2 plus 2, and then b, 4 plus 2, And C, 6 plus 2. So your final answer is minus 9a to the 4, b to the 6, c to the power of 8. Question B, we have the same thing. We have a bracket, which is raised to a power of 3, but inside our brackets, we also have variables with exponents. So when we raise it to a power, we multiply our exponents. So minus 2 cubed is going to give us minus 8. X 2 times 3 gives you 6. Y to the power of 1 times 3 gives you 3. And then Z to the power of 3 times 3 gives you 9. And that's your final answer. C, we don't have any powers outside of our brackets, which means we simply add our exponents. Because we're multiplying factors here, we're adding the exponents. So we have a minus m, because a minus m times a positive m is minus m, then times a positive gives you negative again. So this is to the power of 1 over here. Then we have to the power of 2, so it's plus 2. And we have to the power of 3 as plus 3. Then let's look at our ends. We only have positive ends. We have 2 plus 1 plus 3. And you're left with a negative m to the 6 and n to the 6. So question 3D, we are going to have to multiply our exponents because we have brackets raised to a power. So let's start off, and we have 2 squared, because remember, always square the coefficient of the variable as well. Never leave that out. So 2 squared is 4. 4y, 2 times 2 is 4. And z, 1 times 2 is 2. Then we have x to the power of 1 times 3, which is x cubed. And z to the power of 1 times 3, which is z cubed. Minus 4 squared gives you minus 16. And then x 2 times 2 is 4. And y 1 times 2 is 2. If you're not, excuse me, if you're not sure what the exponents are, if they're not written down, you can just write a 1. Okay, any exponent, any variable that doesn't have an exponent, that exponent is 1, because anything to the power of 1 is that number itself. Now we are multiplying, which means we're adding exponents. So we are going to have a 4 times minus 16, which is going to give us minus 64. Y to the power of 4 plus 2, because we have a y here and we have a y here. And then we have z to the power of 2 plus 3 with this z and that z. And then we have x to the power of 3 plus 4 with that x and this x over here, which means we have, if you underline them as you're striking them off, you can remember to not miss out on any of the variables. So you're left with minus 64 y to the power of 6, z to the power of 5, and x to the power of 7. The last question, E, we have a fraction, which means we need to try and get rid of the denominator. Once again, we can do it 2 ways, so I'm going to show you both ways of doing it. The first way of doing it is to take out what's common. So what's common between the two of these is x3y. X to the power of 3y, and you're left with 4x to the 5, y to the 4, all over x cubed y, which means we can cancel those, and you're left with 4x to the 5, y to the 4. An alternate way of doing it would be to just simply bring the denominator up to the numerator and change the sign of the exponent. So we can say 4x to the 8 minus 3, y to the 5 minus 1, and you're left with 4 x to the 5, y to the power of 4. Same answer, two ways of doing it.